Alrighty guys, welcome to day 7 of Advent Decode. 30 seconds here to the question is released. Yesterday's went okay, wasn't too hard of a question, but I just totally messed up my implementation. Definitely could have done better programming wise, but when I'm doing these to trying to be fast but also be informative, I kind of have to stick with what I go with and just go with it and can't really change. But at any rate, let's see what today's question is. Hopefully it goes better. Day 7. Let's do this. In 3, 2, 1, let go. You landed at the regional airport in time for your next flight. In fact, it looks like you even have time to grab food. All flights are currently delayed due to issues in luggage processing. Due to racing aviation regulations, many rules are being enforced about bags and their contents. Bags which are color coded and must contain specific quantities of other coded color. That's a tongue twister. Bags. Apparently, nobody responsible for these regulations consider how long they would take to enforce. Following rules: light red bags contain 1 bright white bag, 2 mute yellow bags. Dark orange bags contain 3 bright white bags, 4 mute yellow bags. Okay, these rules specify the required contents for 9 bag types. In this example, every faded blue bag is empty. Every vibrant plum bag contains 11 bags, 5 faded blue. Okay, so on. You have a shiny gold bag. If you wanted to carry it in at least if you wanted to carry in at least one other bag, how many different bag colors would be valid for the outermost bag? In other words, how many colors can eventually contain at least one shiny gold bag? Okay. What's our puzzle input? Oh goodness. Alright, so there's gonna be a big parsing scheme here. Okay. Whoops, not there. So this is going to be some serious parsing. Okay. Oh no. If I want to carry it in at least one other bag, how many different bag colors would be valid for the outermost bag? So a bright white bag which can hold your shiny yellow gold bag directly. So we need to build a tree. Oh. Okay. So what we need to do is we need to build a kind of mapping system. So we take in all these, we put them into a kind of a tree system, and then from the top nodes we see how many of these can contain a bag in them. I guess is probably our best bet. Okay, and we can speed this up by kind of doing stuff. Okay, so what we're going to do is first parse this input into something we can understand. So it looks like bags contain... Okay, let's try and parse this. So it's first going to be something, bags contain, number, something, bags, comma. Okay. So first thing to do is break it on bags contain. Yes. Day 7. So we're gonna have to go through each of the input string s in inputs. Let's first do, I'm going to keep doing the splits. I like splits the most. I think it's the best, just quick way to do things. So we're going to split on bags contain. I keep going back to the wrong place. Okay, so this is going to be the split one. This is going to get very weird if I just do split one. So string this, split one. So we're going to split the input on that. So that's going to give us that. So what we can do is we can do string outer bag equals split 1 0. So there's the outer bag all figured out there. And so now we're on to the rest of these. So the rest of these can now be splits on the comma when remove the last bit. Okay. So actually we can do, before we do the split, we should do s dot substring. Let's go from 0 to s dot length -1. We're doing this just so that way. It's actually -2. Sorry, -2. We're doing this just to remove this last period. This period is irrelevant. We don't need it. So good. Okay. There. So now we can do string inner bags. Actually, it's going to be this inner bags, and it's going to be splits 1 1, and then we're going to split this on commas. And is that it? Does that do it? Oh, because now we have quantity and then that. Okay. Okay, so now we have the inner bag. So now what we need to do is we need to do a for loop on this. So string s inner bag. This is actually, and this is going to be just inner bag. So we're going to go through all the inner bags and we need to get their quantity. So int quantity. First we actually need to do int index is going to be inner bag index of the first space because we want to go from the first space. So what we're going to do is the quantity is going to be integer parseInt of our inner bag substring from 0 to index. There we go. So it's like our quantity, and then we're going to do string bag name is going to be the inner bag substring index plus 1 to the end. Okay, so let's just verify that these are parsing correctly. So let me just do a system out print line here. This is gonna spam a lot of stuff, but let's just do quantity plus dash. Let's not even do any spaces just to better verify, and then bag name. Okay, run this, verify. I should have also included the outer bit there. Oh, nope, for input string, are there blank lines? Oh, where is this? Inner bag, there's no space. Oh, if it's empty. Bags contain, oh, so if it's no. Well, it should still. So comma there. We're splitting on spaces. We didn't put. Oh wait, this didn't even output anything though. What's going on? What's inner bags? It should have gotten something at least. Oh, sorry, inner bag, not inner bags. There is a input. Okay, so we need to quickly do a trim on this. There's a space there and it doesn't like that space. Actually, we could probably remove it. Right, because we can do bags contain and then 3, and then we're splitting on this, so we shouldn't remove. We shouldn't remove the space. That'd make our life easier if we don't move the space there. Actually, we can do it there and there. Let's see what this does. Does this help us out? Okay, so for no. So index. So we need to actually get string quantity string. So we do this, and what we need to do is we quickly need to check if quantity string equals ignore case no. If it does, we need to do something. I don't know what for now, but otherwise parse like we were just doing. Quantity string. Okay. Good. Good, and it looks like it's parsing A-okay. Sweet. Oh, but there's now bags, bag. Oh. We don't want bags or bag. One thing we can do is we can replace all bags and bag on these and just remove them. We don't care that it says bags. I mean, we could just use as is, but so what we're gonna do is actually replace, and we're going to replace bags with nothing and replace bag with nothing. That should address that issue. And then we can go ahead and just trim. Okay. Ooh, why is there, okay. Get rid of that, get rid of that. Sorry, getting these parsings, like, why is one drab turquoise back? What is that doing? Oh, I must be removing too much on the end there. Oh, because it's exclusive. My bad. I was removing too much at the end there. There we go. Okay, so now we're good. So now we've parsed these all in. So now we need to put these into a giant kind of map for a bag. So now we need a hash map string. This is the bag, and this is a list of, whoops. We're gonna need a wrapper class here, public, static, bag info. Let's just call it bag info. That works for me. Class. And this, all this is gonna do is just gonna hold info of the bag. It's gonna hold the counts, and it's going to hold the bag. Both these are public, and we're gonna hold this information about it. So what we're gonna do here is when we get to this, it's going to be bag info equals new bag info, and we're going to set the quantity, not count, bag info quantity there, and bag info bag name. Good. So now I'll put that. So now we have the bag info. So now we can do this. Okay, that's gonna be bags equals new. I'll just do map or hash map. Sorry. Okay, so now we have this bag. So what we can do is if we get to here, we can just do bags. We can just put in the outer bag with an empty list. Otherwise, actually no, we need to do this way, because this is the inner bags. We need a list here, so list of bag info, if I can spell. Okay, and so now we have this, and we actually don't want to do anything, so we only want to do this if it is not null. Bag infos, I guess. And now we can simply just add bag info to this. Okay, and so now there's that, and then after we do this, we go ahead and put bags. We insert into bags. We put the outer bag in with the bag infos. Cool. So now that we've done that, so now we have this big giant hash map of all the bags. So now we need to figure out what, is it a golden bag? We need to figure out how many bags can eventually contain one shiny bag. So what we need to do is we need to do this recursively. So we're going to do one thing that can help us here. We're going to make one more map, and this one's going to be a string with an integer. And what this is going to do as we find bags and how many, as we find a bag and we find out whether or not the bag does have a shiny Boogle bag, we can add it to this, and that way we can reduce our time of searching through things. So you'll see here in a second. So Boolean bag cache, I'll call it. This isn't totally necessary, but I'm going to do it. So what we're going to do is we're going to go through all of the bags, string bag and bags key set. We're going to go through all the bags, and we're going to determine whether or not this bag is in the bags. So we need one more method down here. It's going to be public Boolean is bag in, or is gold bag in bag. Is gold bag in bag. Oh my goodness. This is rough. Okay, so what we're gonna do here is go through each bag. We're gonna go is gold bag in bag, give it the bag, give it all the bags, and we're gonna give it the bag cache here, just because. We're gonna update this method, or we're just gonna create a new one. Okay, and so what we're gonna do here is we have the bag, now we need all the bags, so we need to go through each bag again. And what we need to do is it's going to be recursive in a sense. So we're gonna go through each bag, and we're going to essentially ask is this bag in the bag? And we're going to have to go through until we find a bag that isn't. Actually, sorry, this shouldn't be bag. This should be a list of bags here. Sorry, string. Okay, so we have the bags. We need to go through each of the sub bag here, I believe. Go through each of the sub bags and ask ourselves if this bag is in there. So, oh boy. We go through each of them and we ask if it's in there. This is where we get into, how does this work again? Because this is hard in the head. Because it contains that, so none of these are golden bags. If there are none of them are golden bag, then we have to go into them. So first we need to do is we need to check boolean has gold. First we need to check if sub bag name equals ignore case shiny gold. Any of them are shiny gold, then we can just do this equals true and return, or break. Actually, it'd be return true. So actually, we don't need this. If any of them do, we return true. This is a boolean, by the way. We return true. We found a gold bag. It's good. Otherwise, if we get to here, we know it's no longer in the bag. So now we have to go through each of these and we have to recursively call into them. That's really being annoying. Okay, we have to recursively call into these bags and figure out if they are there. So we need the mass. Okay, we're gonna make this, we're going to make these outside here because this is kind of dumb that we're doing it this way. We're passing it through. This shouldn't be passed through as variables. It's annoying. Very kind of pointless. Okay. We just give it the string bag, so now we can just do all we need to do here is we just need to do bags get bag. Okay. And then now that we have determined that it's not there, when you go through each of these again, but then when we go through each of these again, we have the bag info. So we first need to check if the bag cache contains the sub bag name. If it does, we just check if the bag cache gets the bag name. If the bag cache already has it in there, we can return true, which actually we need to do here. Or no, we should do here. Okay. So we get to this point and we should just do bag cache. Or no, it's not needed here. This is only needed when we do the sub. Okay, hold on. This is one of the harder ones. That's harder to process through because there's just the layers of recursion. Recursion is a little hard to work through in my head and talk about it. Sorry about that. Okay, so now we have our bag cache. So in this case, the bag cache contains this bag, so we can just return whatever. We just return true because the bag cache contains it and we have it as true. Otherwise, if the bag cache does not contain it, that means we have not processed this bag. So now we need to recursively call into this and do it here. And in this case, when we recursively call into it, we get the results contains, and then what we can do is we can now update the bag cache, and we can put the sub bag in here and contains, and now we can just return contains. There we go. And then down here, return false. Good. All right. I think this might do it. I'm gonna run this just to see. Well, that's not gonna be. Oh, we're gonna get null pointer anyways. What am I getting null pointer about? Bags. But bags is defined out here. Bag infos, outer bag. I'm not sure why it's giving me null pointer. 1 second. Let me do this. Let's do this with their demo, their existing code. That way we can test it on the known first. Make my life a lot easier. So getting null pointer. What's null? Bags isn't null. Whoops. What is null here? How is bags null? This I don't understand. How is bags null? Interesting. Okay, I don't understand. Never mind. I must, with how my thing works, this must be kind of weird. All right, anyways. So now we get a new null pointer and we're gonna get it here. So we have a null pointer on the sub bag. There should be no null sub bags. I'm gonna guess that's what it is. It's either sub bag or bag name is null. Again, more debug stuff. This is the process of when you do something like this where it's not fully able to understand. I guess it's going to be this. Well, we can know here. What is bags? Where are we getting? Wait. Are we getting bags as null again? Okay, no. Is that null? Is bags get bag null? Okay, so if it is null, we need to add a check here. If it's null, that means the bag somehow has not been processed, which doesn't quite make sense. What bag is this that's not been processed? Bright white has been processed. Interesting. Okay, let me see what the contents of bags are. Light red, muted yellow, dotted black, dark olive, bright white. Bright white. Is there an issue on the outer bag? Do we need to do a split here? I think we need to do a trim, not a split, a trim, sorry. There we go. Sorry, trimming because of the parsing is a little bit weird. Okay, so we figured that out. So now we just need to know, go through this. We need to count, int count here, start 0. We just do a simple check. If it is in, if this is true, that means there's a golden bag in here. Now we can just do a count plus plus, and we can just do a system out print line part 1 count. Okay, run that. Our example gives us 4, which is not what theirs does, right? Oh no, it is 4. Okay, so let's run our code in, or run our puzzle input in. What do we get here? 35. Please be right. I don't want to debug this. I didn't want to debug this. So theirs is 4. Ours is not 35. Oh boy. I don't fully know. what would be the issue here? Whoops, I just closed the input. So it should be 594. Let me just quickly output our bag size. Bags size should be 594. There is. Okay. Let's remove the cache. Let's take the cache out of this. So we take the cache out of this. We simply do this and ignore the cache. Okay. So this should be cache-less right now. Without the cache, we get 11. Oh no, this is probably the first one where we go downhill with my recursive methods. Alright, time to debug chat. I'll be right back. Oh, I think I know what's going on. I think I'm returning too early. I should be only returning if this is true. I should be only returning if it contains. So that's kind of a miracle that it worked for the smaller one. There's still no cache on this, but it's still saying 4. So now if I put back my input, we're going to get 131, which seems much more likely to me. You got it. Okay. Well, luckily in the end it wasn't too bad. There's no cache still on this. The cache is still gone. So in theory we could add the cache back. I'm just going to remove it for right now. There's no sense for me to include the cache in the end if we're not actually going to use it. But if you want to make this faster and improve it, you could add that bad cache. So just know about that. Okay. Part 2. It's getting pretty expensive to fly these days, not because of ticket price, but because of the ridiculous number of bags you need to buy. Consider getting your shiny bag and rules from above. Okay, so a single shiny bag must contain one dark olive bag and 7 bags within it. Of course, the actual rules have a small chance of going several levels deeper than this example. How many shiny golden bags must contain... Oh, sorry about the train. In this example, a shiny gold bag must contain 126 other bags. How many individual bags are required in your shiny gold bag? Okay, so using this, we still want to go with this. What we want to do is we want to now count. So we can actually just do another thing on top of this. We just can do another method here. It's like, we can just do a part 2, and we can just make this int count bags in gold bag. Okay. And then we can just call this. Okay, and so what we need to do here is we need to go into, we need to first get the bag info of the gold bag, equals, actually we should probably pass this into here, but either way, for right now, one iteration. Whenever you're starting a recursion, you always want to deal with one iteration first and then add the recursion to it. So you want to go bags, get, and it's shiny gold is what we're looking for. And so this bag info now we need, so now we need to go for this is the wrong thing. Sorry, this should be a map of bag info. And we have int count is going to be starting at 0, and then for bag info in gold bag. That's supposed to be that. What we got to do is we want to do count plus equals bag info dots quantity. So that's how many are in it, but then we need to then also add this, and we want to give it the bag info. Okay, so what this is going to do, this is going to take in, sorry, it's going to take in a string for bag, so bag info, bag name. Okay, do that, bag, and then when we call this the first time, we need to provide it that. Okay, and so this is just going to be bag list, I guess. Okay, and so then there's count, and then we can return count. Okay. So let's see this. Let's again try this on their example code. So there should be 126. Are we right? No, because we get 12. We get 0 and 12. What? Oh. So it should be containing 126, which it doesn't. So it's 2 and then dark red. Oh, this is multiplication, not addition. This is gonna be quantity times whatever's inside of it. Which we get, okay. So what we want to do is actually when we get to the very bottom, the count inside of the bag is the bag itself. So we should just check if bag list equals 0, return 1. Is this right or is this wrong? 64. I think we always need to start count at 1. 127. But we're counting the golden bag, so we need to subtract 1 because we don't want to count the golden bags, how many are inside of it. All right, I think we've got it now. So it's 126. Let's switch back to our inputs. And how many do we have? That many. We'll dump this into our answer. Hey, we did it, chat. How badly did we do today? Bad, yeah. The first one, it's for me, recursion just takes a second. And I try to get a little too cute with it and try to have a bag cache and all that. I shouldn't have tried that. I should have just gone with recursion, just gone full force recursion, just gone with it, and I would have done so much better. But anyways, let me explain this and we can go over how this is done. So the question for today is you have a bag, and inside that bag are bags, which inside those bags are bags. Basically, you have a bag that has a bunch of bags inside of it, which have bags inside of it. So what we need to do is the first part wants to know how many top level bags, if you just had a bag in front of you, what I guess there's a bunch of color bags. So of all the color bags, how many of those have to have a gold bag inside of it due to the rules of what a bag contains about it? So what we need to do is we first need to read this monster of an input. I should really get a base system for parsing inputs like this because this has been done a lot before. But we need to parse this input in and take the parent bag here and put it into a hash map with the value of the parent bag being a list of all of the sub bags with their count and the bag name. Then once we make that giant hash map up, we need to now go through and for all the parent bags, so basically if you had a bag in front of you, it's a parent bag. For all those parent bags, how many of them have a gold bag inside of it due to the rules about what we just put in the hash map. So what we do is we just go recursively through, for each of the bag, we say, do you have a gold bag inside of it, which triggers the recursion, which goes through each of the bag and below it and keeps going through the recursion tree until we hit the bottom, until we hit a gold bag in there, which we return true up, or we hit the bottom of the bag, in which case none of the bags have a gold bag, and then it gets returned up as false, and this goes through. So yeah, it's again, you just need to know recursion. You need to get into recursion and better. Recursion is your friend in this case. And then the second part, again, recursion is your friend. We want to start with the gold bag and count how many bags are inside of it. The key to note here is that it is the quantity times the bags inside of it, because if you have a bag with 4 red bags, you're going to be counting how many bags are inside of a red bag, but you need to multiply that by 4 because there are 4 of them in there. And then return up. Make sure your count starts at 1 because the bag you are in starts as 1, but because we don't want to include that gold bag in the first count, we then subtract 1 out. Hopefully this made sense. Recursion is a bit hard for me to explain. I'm not the best at explaining it. I can explain what recursion is, but explaining recursion in the scope of a problem is a little hard for me. So hopefully this made sense. Anyways, today's problem done. A little bit longer than I hoped, but there we go. So anyway, I'll see you guys tomorrow for day 8. Peace out.